You believe the past is permanent, that what has happened cannot unhappen, that history is written in stone, fixed and unchangeable. You remember yesterday. Records exist, photographs, documents, memories stored in your brain and in the collective knowledge of humanity. The past feels solid, knowable, real, but the universe does not keep records. Not permanently, not in any form that lasts. There is a process written into the laws of physics that slowly, inexorably erases everything that has ever happened. Not just the memory of events, not just the records we keep, the information itself, the physical fact that something occurred. This erasure is not a flaw in the system. It is not something we can prevent or overcome. It is a fundamental feature of reality, as inescapable as gravity. And at the heart of this process are objects so strange, so extreme, that they challenge everything we think we know about information and existence. Black holes. Regions of spacetime where gravity is so intense that nothing can escape. Not matter, not light, not information. They are cosmic erasers, consuming everything that falls into them and leaving behind no trace, no record, no memory. When something falls into a black hole, it disappears. Not in the sense that we cannot see it anymore, in the sense that the information about what it was, the precise arrangement of atoms, the history of its existence, every detail that made it what it was is destroyed, or so it seems. And this creates a paradox, a fundamental conflict between two of the most successful theories in physics. Quantum mechanics says information cannot be destroyed, that the universe keeps a perfect record of everything that has ever happened, encoded in the quantum states of particles. General relativity says black holes can destroy information, that what falls in is gone forever, irretrievably lost. Both theories have been tested thousands of times. Both work perfectly within their domains, and yet they contradict each other on this fundamental question. Can the past be erased? The answer to that question changes everything. Because if information can be destroyed, if history can be truly erased, then nothing is permanent. Not your memories, not your accomplishments, not the records of civilization. Everything you think is preserved will eventually be consumed by the cosmic erasing process, and when it is gone, it will be as if it never existed. The universe is not a library, it is a fire, but neurons decay. Connections weaken, the brain ages. Eventually, if you live long enough, you will forget most of your life. Not because you chose to forget, because the physical substrate that stores the information deteriorates. The signal gets corrupted by noise. The patterns dissolve. And when you die, those memories die with you. Unless you wrote them down, recorded them, shared them with someone, they are gone. Permanently. Irretrievably. But even writing them down does not preserve them forever. Paper decays. Digital storage degrades. Hard drives fail. Servers shut down. And even if you could somehow preserve the physical records in a vault protected from entropy, eventually the vault itself will be destroyed by geological processes, by the expansion of the sun, by the heat death of the universe. Nothing lasts? Not really. Not fundamentally. Information persists only as long as the structures that encode it remain intact, and no structure remains intact forever. The universe trends toward disorder. This is the second law of thermodynamics. Entropy always increases. Order becomes chaos. Patterns dissolve. Information is lost to noise. For most of human history, this process was slow enough that we could ignore it. Records lasted longer than lifetimes. Stories passed through generations. The past felt stable, knowable, permanent. But the universe operates on longer timescales than we are comfortable with. And on those timescales, everything fades. Everything is forgotten. Everything is erased. The question is not whether this happens. The question is how. And the answer involves some of the most extreme objects in the universe. This radiation carries away energy. And since mass and energy are equivalent, a black hole loses mass, It evaporates slowly. A black hole with the mass of the sun would take 1067 years to evaporate completely, but eventually it would disappear. And when it disappears, what happens to the information that fell in? The Hawking radiation is thermal, random. It does not encode the specific details of what fell into the black hole. It is like heat, generic, structureless. If the black hole evaporates completely and the radiation it emitted contains no information about what fell in, then the information is destroyed. This is the black hole information paradox, and it has tormented physicists for 50 years. There are several proposed solutions. Perhaps the information is not destroyed. Perhaps it is encoded somehow in the Hawking radiation, in subtle correlations we do not yet understand. Perhaps the information escapes at the last moment, when the black hole evaporates completely. Perhaps there is no true singularity, and information is preserved in some structure we cannot yet describe. Or perhaps, and this is the disturbing possibility, information really is destroyed. Perhaps quantum mechanics is wrong in this regime. Perhaps the universe does not keep perfect records. Perhaps the past can be truly erased. We do not know the answer. Not yet. The paradox remains unresolved. But what we do know is that black holes are engines of forgetting. Whether they destroy information or merely scramble it beyond recognition, the result is the same, from a practical standpoint. Once something falls into a black hole, it is gone, irretrievable, unknowable. And the universe is full of black holes. Millions in our galaxy alone, billions in the observable universe. They are consuming matter constantly. Stars, gas clouds, planets, perhaps even entire civilizations, if any existed close enough to an event horizon. Every second, somewhere in the universe, information is falling into black holes. And every second, the cosmic record shrinks. The past is being erased, event by event, bit by bit. And as they evaporate, they will release all the information they ever consumed, if information is conserved, or they will carry it into oblivion with them, if information can be destroyed. Either way, by the time they are gone, the universe will be cold, dark, empty, maximum entropy, no gradients, no structure, no complexity, and in that final state, there will be no record of what came before. No way to reconstruct history. No way to know that stars once burned, that planets once formed, that life once emerged, that consciousness once asked why. The universe will have forgotten itself. Now bring this back to human scale. Your life, your memories, your accomplishments, you assume they matter because they happened, because they are real, because the past is permanent. But the past is not permanent. It is preserved only in structures that will not last. In your brain, which will decay. In records, which will be destroyed. In the arrangement of atoms, which will be randomized by entropy. And eventually, on timescales that are incomprehensibly long but still finite, even the information encoded in quantum states will be scrambled beyond recovery. Whether by black holes or by the relentless increase of entropy, the past will be erased. Your life will be forgotten. Not in the sense that no one remembers you, in the sense that no record remains, no trace, no echo. It will be as if you never existed. The erasure is total, absolute, final. This is different from ordinary death. When you die, at least the effects of your life persist. Your children, your work, the people you influenced, the changes you made to the world, these effects propagate forward, shaping the future in ways that would not have happened if you had never existed. But if those effects are eventually erased, consumed by black holes, randomized by entropy, then even that consolation disappears. The future you shaped will be forgotten. The chain of causation will be broken, and it will be as if you never influenced anything. Perhaps the most disturbing implication is what this means for knowledge. We assume that knowledge accumulates, that what we learn becomes part of the permanent record, that science builds on itself each generation adding to what came before. But this accumulation is contingent on preservation, on information persisting long enough to be transmitted. And in the long run, information does not persist, it decays, it is lost, it is erased. Imagine a far future civilization that emerges after billions of years, when all record of our civilization has been destroyed. They would have to rediscover everything. Physics, mathematics, history. They would have no way of knowing that we had already figured these things out. No way to benefit from our knowledge. Or worse, imagine that no future civilization emerges, that humanity destroys itself, and the black holes and entropy erase all evidence that we ever existed. Then, everything we learned, every scientific discovery, every philosophical insight, every work of art will be lost permanently, forever. The universe will not remember that we knew how stars work, that we understood quantum mechanics, that we sent probes to other planets, that we asked questions about our own existence. All of it, gone. I do not know which interpretation is correct. Perhaps both, perhaps neither. What I know is that the universe forgets, black holes erase, entropy increases, and in the end, the past will be gone, not just forgotten, erased, deleted from reality. The history you think is permanent is temporary. The records you think will last will decay. The memory you think defines you will dissolve. And when it is gone, when the last trace has been erased, when the universe has forgotten everything that ever happened, it will be as if none of it ever occurred. The past is not written in stone. It is written in patterns, and patterns dissolve,